going to look at homework pages 41 and 42. As we take a look at number 1, we're looking at basic facts, but we're looking at facts that have a little bit more complex factors. So you'll notice we no longer have our easier ones, and we're getting instead numbers of 6s, 7s, and 8s. So the important thing to remember is that we can always go ahead and use strategies to help us figure these out. For example, if we look at 8 times 4, it might be easier to think of it as 8 times 2 and then double. If we do 8 times 2, it's 16. To get to 8 times 4, all we have to do is double it, and we would get 32. 6 times 5, hopefully we can count by 5s pretty easily. We would get 30. 7 times 7 is probably one of the more challenging facts because there isn't an easy way to do it. My recommendation would actually be to think of this as 7 times 5 plus 7 times 2, because we know that 5 plus 2 equals 7, so we're still going to have the same answer. It's easy to do by 5s. 7 times 2 is 14, and now I have to just add these two numbers together, 35 plus 14, which would give me 49. 6 times 8 might be easier to think of it as 6 times 4. And then we would just double that because 4 doubled is 8. 24 plus 24 would be 48. And then 6 times 6, 36. So the second row, we're going ahead and we're looking at instead actually division, but we can think of it as multiplication where we only know one of our factors and we also know our product. Remember, our product is the answer. So now we need to think about how we're going to solve this. And if I look at my first one, which is 8 times something equals 56, one of the easiest ways might be to make a ratio table. So if I draw that ratio table out, one group of 8 is 8. I double it, 2 groups of 8 is going to be 16. Double it again, 4 groups, so 16 plus 16, draw a little line right there, would be 32. If I double it again, I get 64. I know that that's too high because my total answer that I'm looking for is 56. So I'm going to notice that if 8's too high, it's just 1 8 too high, and my answer would actually be 7. 9 times something equals 63. So again, I could think of it as a ratio table, and I could start going by groups of 9. 2 groups of 9 would be 18. 4 groups of 9 would be 36. 8 groups would be 72. Again, I'm noticing that I'm too high, so now I need to ask myself, how much am I over? Well, I'm 1 group over, so therefore I can figure out that my answer is again 7. Next ones, we're going to just multiply by 5s. We can count in our heads, 5, 10, 15, 20, 25. Next one, we're looking at 6s, so we're counting by 6s. It might be able to use a fact like 6 times 6 is 36. How many more 6s do I need? Just 1 more. And then if I look at my 8s, I actually could go all the way back over here, and I have my answer that 8 times 9 is 72. Thinking about practicing facts, the big thing that they want you to notice is that, well, we're multiplying by 10, so our point is to say, try again, 5 times 10. And when I multiply those together, I get 50. Next one would be 2 times 10, which would be 20. And as I multiply these out, I'm going to keep going across. The next section, letter B, you're noticing is 5. Well, 5 is half of 10. So all of these answers are going to simply be half. And so on. Now C, we tend to look at it, and we notice that it's times 9. So what that's basically telling me is that I'm going to go back to my tens and I'm going to just take away one group. So if I know that 5 times 10 is 50, 9 times 5 means I'm going to take away one group of 5 to get my answer of 45. 2 times 10 is 20. If I would take away 2, I get 18. 9 times 10 is 90. If I take away 9, I get 81. And 3 times 10 is 30. If I take away 3, I get 27. So looking at number 3, it says use what you know about multiplying by 10 to help solve these problems. Their goal is to get you to split apart your number that's greater than 10 and instead to think of it as 10 times 10 and 2 times 10. When you do that, you're going to add up your answer to get 120. And that's your goal as you do it all the way across. So 10 times 5 and 2 times 5, 10 times 9 and 2 times 9. Each time I'm breaking apart my factor that's bigger than 10. 10 times 5 and 8 times 5, 10 times 10, and 8 times 10. So once you figure out each of those, you're going to just add up the answers and you'll get your actual total answer for your product. On the back side, we're looking at different strategies for solving division. And in front of you, you will see that there are 4 different ways that we talk to students about how to divide. In this particular problem, our division is saying 29 divided by 3. And there are 4 different ways that we can actually go ahead and do this. So the first way is we can share out or deal out 1 by 1, which means that we would take 3 groups and we would simply be putting 1 in at a time until we get all the way up to 29. By the end, you would have 7 in each and 1 left over. If you share out in bigger chunks, it means that you're going to take those 3, but you're going to think of it as, what could I do that would be larger? Oh, you know what? I'm thinking of the last one. I'm like, it's not 7. It would be 9. We'll stick 2 more in each of them. Good to double check. All right. 9 times 3 is 27, and then we have 1 extra left over as well. So then we're saying bigger chunks. We could do 5s. That would get us to 15. Maybe I'll put 2 in each of them. Gets me to 21. Maybe I'll put 2 more in each of them. That gets me to 27, and then I have 2 left over. Skip counting means that we're more using a number line, and on that number line we would be counting by 3s. Another strategy that would work for doing this: 24, 27, remainder of 2. And then the last one is to use multiplication facts that you know to go ahead and help you. So we know that 9 times 3 is 27, which means we'd have a remainder of 2. So now that we've looked at the 4 different ways that we can go ahead and divide, we're going to choose one as we look at question 4. Mrs. Larson was making gift bags for the 6 students in her reading group. She was putting little erasers in the bags. She had a bag of 20 erasers. How many erasers did each student get? Show all your work. So we're going to go ahead and set this up as a division problem. 20 is my total, divided by 6 students, and I'm going to put the letter E for erasers as my answer. If I were to draw a picture of this, I would draw 6. And then I would ask myself, what could I put into each of these circles? Now, you could do it 1 by 1 and keep adding up until you get close to 20. But I'm going to go ahead and think to myself, well, if I did 1 times 6, it would be 6. 2 times 6 would be 12. 3 times 6 equals 18. And then beyond that, I would be too far. So what if I put 3 in every single one of these circles? I double check, yep, I get 18 with a remainder of 2. So how many erasers did each student get? This circle represents one student. So each student gets 3 erasers. With 2 left over. All right, looking at number 5A, it says the teacher wanted his class to work in groups of 4. After he divided them into groups, there were 6 groups of 4 and 1 group of 3. How many students were in the class? So you could either draw this out with pictures or you could write it out with numbers. If you wrote it out with numbers, I would say there are 6 groups of 4. If you drew it out with pictures, there are my 6 groups, and in each group I have 4. Plus, it says there is 1 group of 3. How many students were in the class? Well, 6 times 4 is 24, plus 1 times 3 is 3, so it looks like there were 27 students in the class. B says, if the teacher wanted all the groups to be exactly the same size, how many students should be in each group? How many small groups would there be? Show your work. So I'm going to use my 27 students. Students may remember this is very similar to our story that we read called A Remainder of One with ants. In that example, there were 25 ants, and we had to go ahead and figure out in which way could we make it so that it was all even without any remainders left. So in this example, we're going to have 27, and I could say 27 divided by 2. Does that give me an answer with no remainder? The answer would be no. What if I tried 27 divided by 3? Well, let's think about it. If I know my 3's facts, I might actually be able to say to myself, 3 times 10 equals 30. If I took away 1 group of 3, would that equal 27? It sure would. So my answer would be 9. So how many small groups would there be? There would need to be 9 small groups with 3 students each.